Recording as well as it's Thursday, October 30th. We're going to take today to do a lab day. You guys remember last few days when we talked about energy, forms and energy, conservation of energy. These are forms of mechanical energy. You guys remember that? Okay. And then one of the puzzles we're looking at had to do with this right here. You guys remember pendulum maximum speed?
Yeah.
So today, you guys get this lab table. Everybody has one of these. And you're going to kind of compare what's the calculated value, which is this column here, compared to the measured value. And you should have a speed gate nearby. Guys, could you turn this big gate upside down that goes through, gives you instantaneous speed? All right, so here, I'll tell you guys a little bit more. This is a real brief overview of what's going on. Now, if you could change different variables, whatever you want, I'm going to recommend keeping mass controlled, which you might see why. Guys, if you change the mass, according to this math, what should change? Yeah, nothing at all. You guys have mass cancels out? Okay. No, if you want to try that out, you can. I mean, that's what science is for, right? To get empirical measurement and see if that's true. Right? You could also change the length. You could also change the angle. This is kind of an exploratory type lab. Okay. If you do any one of those, I would really recommend changing the angle, which is probably the easiest thing to do anyway. Okay, so could you guys take the protractor, measure the angle? You guys know how to measure the angle, right? Okay. If you take the node of the protractor, put it right on this point right here, you zero out the vertical, because this is an angle measured relative to the vertical. When I do that, the sweeps through about, it looks about 43 degrees or so, just on the printed page, about 43 degrees. So that'd be 43 degrees. Guys, it's okay for the angles to be in degrees today because the calculation version, you guys see how the angle is inside a trig function, in this case a cosine? Okay. So as long as you have the calculated program also in degrees, it should say DEG, everything's fine. Radians is really important to use when you're directly multiplying an angle, like if it's not inside a trig function like cosine or cosine. So degrees is perfectly fine today, which is exactly what the protractor tells you. So it's all good. Okay.
Did I miss something too?
Here, I'm going over it right now.
All right.
Yeah, going yeah. All right, then, because guys, near the end of the class, about the last 5 or 10 minutes, I'm gonna have some people volunteer. If you have your angle specifically as an independent variable and everything else is controlled, I'll have you tell me your data, and I wonder what this graph is gonna look like. Like, what is this speed, say like the vertical axis, as a function of a changing angle for your independent variable, your horizontal axis? Okay, all else controlled. What should that graph look like? And we're gonna see. I'll have you guys tell me your actual measured empirical data. Okay? And along the way, you guys can, of course, say, how does your measurement, your empirical measurement, compare to the theoretical calculation? Okay, you guys should do a calculation? Okay? Because, yeah, it's just put the numbers in here. So you guys get a little bit of practice today. You guys get to do some math practice. I'll leave this up over the class today so you guys can refer to this. But really, guys, ideally, you should be able to derive this from scratch, right? Actually, let's go and do this. Let's do this. It's so much your practice. Wait a lot of time. All right, so set up here, guys. What kind of energy right here? Gravitational potential energy. What's the formula for that? MGH. Yeah. So if you know this mass times gravity field times some high change is going to go through, that can represent how many joules of energy in the system there are to work with at all. Right? This could be called the ball Earth system or something. How about by the time it gets to the bottom, what kind of energy? Yeah, it's all kinetic. What's the formula for that? 1 F squared. Guys, is that the same as the Galileo question?
Yeah.
Yeah. In fact, if you solve for speed, the same thing as the crash speed would be. But if you just drop the ball, straight down, have some crash speed. This is how it turns out to have the same speed on a pendulum. It's just moving to the side instead. Same numerical value. Okay. So this is the Galileo question. It turns out to be speed is square root 2gh. This is square root 2gh. It's just a funny looking h. So how do you get h? So let's go through some geometry. You guys see a nice right triangle right there? Okay. Yeah. I mean, what is height in terms of L and theta? You guys get that premise, right? Okay. Yeah, so this side is equal to what times what? L times L cosine theta, right? Get that. Right, because cosine's adjacent. Right? And then, guys, is this length here, this length of this pendulum, equal to this full length right here? Same length. Therefore, this height change, wouldn't that be the full length minus the L cosine theta? Right, guess that? Right, there you go. Just like that. So the final speed should be square root 2gh, or I'm telling you it is. You're going to do the science today and see how it measured up. But this is square root 2gh. It's just the final look at h. Right, guess that? All right, and then for AP, you guys know AP Classroom is due by the time you guys come to class on Monday, which I think, even if you hop on there tonight and start answering some questions, I bet you guys could probably answer any questions just based on what we've done the last few days. All right, so go ahead and do this lab. You got different trials. Just record what lab what you're doing here. Probably leave that controlled. Measure how long, measure the angle, do the calculation. measure the speed of the speed gate. I bet these two numbers are about the same all the way down, and I can walk around, put you guys out, and I'll have somebody volunteer their data so I can make a graph at the end of class.